Alright, so once again, this is Thursday. I will be in and out today doing IEP meetings again, so we're going to make another video so that you can get the notes for today and know what's going on without just having to copy something down. Alright, so right now you should have your bell workout. We're going to go through those, and then when we finish, you're going to put your name on it, turn it into the box that is for your period. Okay? Every end of the week from now on, you're turning these in and getting points for them. Alright? So, Thursday says write an equation for a line of best fit that passes through two data points, 1410 and 16115. Okay? Now, I don't have the data graphed over here yet. Okay? Because this is Monday when I'm making this. And I'm doing this for Thursday. So you need to draw a line that starts at 1410 and goes through 16115. That's going to be your line of best fit. Okay, so do that really quick. Okay, now once again, you should see that that line goes through about the center of all the data points that you've graphed. It should hit a couple points. About the same amount should be on top as there are below. Alright, now we're going to write an equation for that line. Alright, now how do we do that? To write an equation, we need two things. We got to have the slope, we got to have the y-intercept. Now, slope, I know it's out of focus. Okay. Slope is going to be y2 minus y1 over x2 minus x1. Okay. Label them x1 and y1, x2 and y2. So when we substitute in, we've got 115 minus 100 over 16 minus 14. And that is 15 over 2, which you can leave it as 15 over 2, or you can simplify it down if you would like to 7 1/2, either way. Alright, I'm going to leave it as 15 over 2 because that is a simplified fraction. Alright, so I'm actually going to leave it right there. Now we're going to take the slope, which is 15 over 2, and 1 point, which is, it doesn't matter which one, I'm just going to pick the first one. Okay, and we're going to say, we're going to plug this into y equals mx plus b so we can solve for b. The y should be 100 in this case. The m should be 15 over 2 times 14 plus b. Alright. 15 over 2 times 14 is what? 105. Check me on that. Okay. Plus b equals 100. We subtract 105 from both sides. And we get b is equal to -5. So when we write our equation here, we've got y equals 15 halves x minus 5. Okay? Now for Thursday, we'll take the equation that we just found, the second Thursday one. We'll take the equation we just found and predict how much it'll weigh if a hamster was 19 centimeters. So we're going to say y equals 15 over 2 times, instead of x, we'll put 19 minus 5. 15 over 2 times 19 should be what? Okay. Should be 142.5. Subtract 5 from that, and we get y is equal to 137.5. And our units here is grams. Okay? Any questions there as to what we would be doing? If so, it's the same thing we did last week. You've got to find the slope up here. Use the slope in one point to find the y-intercept. Then when you take the slope and the y-intercept, you make an equation. Once you have the equation, use the equation to find the expected weight of a hamster that was 19 centimeters. Once you solve, that's its expected weight. Okay? Alright, so put your name on that. Go put it in the tray that belongs to your class, and then come back and get the packet that is got the 4 boxes on it with an equation, a table of values, and a graph out. Okay? Alright, so you should be getting back to your seat right now. If you're still standing up, you need to get back and sit down so we can continue. Alright, today what you're going to be doing is you're going to be doing an activity on slope-intercept form. Okay, where in a little bit I'm going to do 4 of them with you, kind of like notes. And then your assignment, you're going to have to write a verbal description, do the equation, the table of values, and then graph it. And you're going to turn this in before you leave. So you're not going to have homework tonight. You have to turn this in before you leave, unless this takes longer than expected, but I don't think it will. And this is going to be checked for correctness. This is not for you and a partner to do. You have to do it on your own. Okay? So the first one's a towing service. And it says, when a tow truck is called, the cost of the service is $10 plus $1 per mile that the car must be towed. Write and graph a linear equation to represent the total cost of the towing service, which is dependent on the number of miles the car is towed. Find the intercept and the slope. Find and interpret the slope and y-intercept of the linear equation. Okay, so we've got this right here. We're going to define our variables first. So, which one's the y? Is it the total cost, or is it the number of miles towed? Okay. In this case, it is the total cost. Alright, your total cost will be your y. And if the total cost is the y, then obviously the x is number of miles towed. Now, we got to write an equation to represent this. Okay? So, we got y equals, so total cost equals, which one's our rate here? Is it the one-time service charge or is it the per mile? Hopefully everybody knows it's the per mile. That's our rate, $1 per mile. So we get $1 times the number of miles towed, x, plus, because it's an additional fee, of $10 for the service. Okay? So far, we've read the verbal description, we've labeled our variables, we've written our equation. Now, we're going to take this, and we're going to make our table of values. Okay? We're going to make our table of values. So in the top, right here, will be our equation. Y equals 1x plus 10. Guys, if you're not writing this stuff down, okay, that's not good. Everybody should be writing this stuff down, paying attention, so that when you have to do this for an accuracy grade, this will be the last grade you get on this report card. Okay? Some of y'all really need to make a good grade on this, so pay attention. We have to pick x values. Now, we don't want to pick -1, 0, 1, 2. And that's because you're not able to tow something negative miles. All right. So let's just be a little more creative. 9 times out of 10, you're not going to get something towed 1, 2, 3 miles. So I'm going to choose 10, 20, 30. Okay, 10, 20, 30, just to make it more realistic, because you're going to probably be, if you need a tow, you're going to probably need it towed a decent little distance. Okay, so now we're going to substitute in. We'll have 1 times 10 plus 10, 1 times 20 plus 10, and 1 times 30 plus 10. Okay. Now we just solve these out. 1 times 10 is 10, plus 10 is 20. So our value here would be 10, 20. The next one, 1 times 20 is 20, plus 10 is 30. And then finally, 1 times 30 plus 10 is 40. So we have 30, 40. Now we got points to graph. We're going to list out the points that we're going to have to graph, which is just our order of pairs here. We got 10, 20, 20, 30. Okay. And then 30, 40. Okay. All right. Now we're going to graph this. Okay. We're going to graph this. Now we got to label our axes. The x values, look up at the top of your paper. The x is going to be what? That's the number of miles towed. Sorry. And then your y value will be your total cost. Okay, now we got to make our grid here. To me, I'm going to space mine out. 20. I'm going to space mine out so I can see it better. I'll do 10, 20, 30, 40. Okay? And you don't have to do the same thing as I did. You can do it however you would like. And then we just graph it. Okay? 10, 20, 20, 30, and then 30, 40. So when we draw, when we draw the line here, okay, we can start it from the start, because what's our y-intercept? What do they charge just to come out there? What's our y-intercept here from our equation at the top? What's the y-intercept here? Is it 1 or is it 10? And it's 10. So this is going to start, if you don't even get it towed a full mile, if you just get them to come out there, it's going to start at 0 miles and it's going to be $10. So we start here, and could you get it towed a part of a mile? Yes or no? Could you get something towed 9.3 miles? And that's absolutely true. So you connect the line. That would be an example of continuous data. Okay? All right. Give you a second to get that down. All right. So everybody should have this. So that's essentially what we're going to do on the next 3. We're going to define our variables, write an equation, make a table, and graph it. And then today, when it's your turn, you're going to make your own description, verbal description, write the equation and all that, do a table, and graph it. And it will be turned in for a grade, an accuracy grade, and it's not a group assignment. Okay, if your name gets left that you are working with partners, that's not good. Okay, you're getting a 0. All right, so let's look at the next one. Your new job is at a custom tee shop where t-shirts are printed to order. For each order, the custom tee shop charges $8 per shirt plus a one-time setup fee of $15. Write and graph a linear equation to show how the total cost of the t-shirts depends on how many t-shirts are ordered. Okay, so we got to define our variables. You've got total cost, and again, number of t-shirts. So which one's going to be our Y? Total cost and number of t-shirts. And it will be the total cost again. 9 times out of 10, guys, if it's total cost, total this, total that, that's probably going to be your Y. Alright, and then the X will be the number of t-shirts, or how many are ordered. Number of t-shirts ordered. Now we got to write an equation. We got Y equals, what is the charge per shirt? And that's going to be 8. So 8 times the number of t-shirts plus the one-time setup fee. You got to pay this fee just to get it set up. And that's 15. Okay? So we've got our Y, we've got our X, and then we write our equation based off the verbal description. Again, we're going to come down here, and we're going to make our table of values. Okay? So let's look at those. And we got 2 more to do after this. So we got Y equals 8X plus 15. X values, don't choose 1, 2, 3, guys. Be more creative. Let's just go like 5, 10, 15. Okay? 5, 10, 15. Because it's based off shirts ordered. You want to be a little creative with this. Alright? So we substitute in. 8 times 5 plus 15. 8 times 10 plus 15. 8 times 15 plus 15. Okay? We're just filling out our table. Some of you are way ahead of me already. That's fine. 8 times 5 is 40 plus 15. 55. 8 times 10 is 80 plus 15 is 95. So we got 1095. Let me try to, there it goes. Okay. And then 8 times 15 is 120 plus 15 is 135. Okay, and then we got to list out our points that we're going to graph. We got 555, 1095, and 15 135. Okay. Excuse me. Now, when we go to graph, again, got to label our axes. Down here, the X value is what you defined your variable as. Number of t-shirts ordered. And your Y value is still total cost. Okay, now when we do our numbers, you got to make sure you have enough. Now, 5, 10, 15, that's not too hard. But what's going to be hard to make sure that it's on there is the Y values. So you got to make sure that you leave yourself enough room to get 55, 95, and at least 135 on there. Okay, so I'll go something like this. We'll say 5, 10, 15, 20, so on and so forth. And on this side, I may go up by 10s each time. So 10, 20, 30, 40, you know, whatever. And just to save myself some time, I'll say 60, 80, 100, 120, 130, and there you go. Now you'll say, well, Coach, you didn't leave yourself enough room. We're going up by 10s. So this is 30. What would that be? 140. I'll get 135 in there. Okay. If I don't, then I'm going to have to erase and start over. In this case, I got it on there. I don't have to erase. So we graph it. We got 555. So at 5 t-shirts ordered, it's going to cost us, there's 40, 55. Okay. At 10 t-shirts ordered, it's 95. So there's 10, there's 100, come down halfway, and that'd be 95. And then at 15, it's 135. So we just looked at 15, go all the way up to 130 and halfway. All right. Now we do want to label what is the cost before any t-shirts are ordered. You got a setup fee, and it's $15, so we can label that. Now, once again, we got to decide: is this continuous? Is this discrete? All right. Can you order partial t-shirts? Answer is no. If the answer is no, we do not draw the line, because that would mean is if you draw the line as continuous, this is discrete. We do not draw the line. Okay. All right. So we're going to move on to the next one. We got 2 more, and then you're going to get to do yours. All right. When a plumber is called, the cost of the service call is $50 for him to show up at your house, plus $25 per hour. Okay. So it tells you what we're going to do. It's the same thing we've been doing. We're going to define our variables. It actually tells you what they are this time, though. Y is total cost. Okay? Total cost. 9 times out of 10, folks, I'm telling you. If you see total cost, that's it. And where X is number of hours. Okay? Now we got to write an equation. Y equals, what's his rate per hour? Okay, what's his rate per hour? Got to have the rate of change first. Rate per hour is 25 times the number of hours. Plus, what's he going to charge just to show up at your house? That's the 50. All right, so that equation is going to allow us to know if he comes out to our house to work on something. If your toilet's backed up and you're not able to get it unclogged, your sink backs up. Happened to me. Your sink backs up and you're not able to get it unclogged. There's some things you're just not able to do at home. They're going to charge you this much just to come out to your house before they ever fix it. Okay? So we take that equation. Y equals 25x plus 50. Alright? Now, again, think about the realistic time period. Is anybody going to come work on your plumbing for 10 hours? No. Hopefully not. If so, you got a bigger problem than you thought you had. Okay? Realistically, 1 to 3 hours is a realistic time. So we can choose 1, 2, 3 on this. Don't choose 0. You don't want to know what it's going to cost if he doesn't work on it. We know he's coming out there to work on it. All right? So we make our table. We got 25 times 1 plus 50. 25 times 1. Sorry, that looks bad. Let me fix that. 25 times 1 plus 50. 25 times 1 is 25 plus 50 is 75. The next one, 25 times 2 plus 50 is 25 times 2, 50 plus 50 is 100. You can probably guess what the next one's going to cost. If he comes out there for 3 hours, 25 times 3, 75 plus 50 more, it's 125. Okay? So, we got our 3 points. Points to graph, we got 175, 2, 100, and then 3, 125. Okay? And now we're going to graph it. Again, we got to label our X and Y. Again, if you're doing the define your variables, this is not hard. Okay, because the X is going to be number of hours. And the Y will be total cost. Now we got to make our scale. All right, I may just say 1, 2, 3, 4. I'm not going to list it all out. Okay, and then I may go up by 25s on my y-intercept this time, or not my y-intercept, my y-axis. So I may go 25, 50, 75, 100. All right, there would be 125, 150, 175, 200, so on and so forth. Okay, you don't have to list them all the way out. Like, you don't have to list 25, 50, 75, 100. If you know your gapping or your spacing, you can just say, okay, you could start at 50, say 50, 100, 150, 200. Some people like to list them all out. I personally like to get a little basis going, like 25, 50, 75, 100, and then I'll start skipping if I need to. That way, everybody knows what I'm going by, but I'm not having to write so much. Personal preference, you don't have to do it that way. Okay, so we graph. At 1 hour, it's $75. At 2 hours, it's $100. And then finally at 3 hours, it's $125. Okay, now let's think back. Again, we want to graph our y-intercept if we can. How much does he charge just to come out to your house before he ever starts working? So at 0 hours, how much does he charge? Look back up top. He charges $50 just to show up. So we can graph that point. Now we're going to decide, do we need to draw the line or not? Okay. Can he work 2 3/4 hours? Can he work a partial hour? Yeah, he can. He can. Now, you will find that in real life, this is a real life scenario right here, you will find that if you hire somebody to come do something, if they get past, like if they work 3 hours and 10 minutes, they're going to charge you for 4. Okay, that's just the way it works in the real world sometimes. But let's just say he's an honest guy and he's going to charge you for the real time he works. So that would be an example of continuous data. All right, so we draw the line. Got one more, and then you're going to do yours. Okay, we're not really having to do that much, so you should be able to keep up with me. But if not, you're going to have to make sure you get it from somebody. All right, your cell phone company, this is another real world one. Your cell phone company charges $20 a month plus 50 cents per text. Define your variables. All right. What do you think your Y is going to be when we're talking about cell phone charges? Probably the same as it's been on every one of these, right? What do you think it's probably going to be? Total bill or total cost. You can put either one. I like total cost better than total bill. Okay, and then X, look over here, it says that the total bill depends on what? Number of text sent. So your X will be your number of text sent. So keep in mind when you're doing this on your own here in a second, to make sure that you have clearly defined two variables. And one's going to depend on the other. Okay? You can use these as guides, but you are absolutely not able to copy one and just change some numbers. Be creative. Okay? These are used for guides, not to copy. So we got Y equals, what's my rate per message? And it's 50 cents times the number of messages plus what's he charge per month, period. $20. Trust me, folks. Now, a lot of people don't have this charge anymore. It used to be a time where you would charge 10 cents per message. But a lot of people don't have that charge anymore. Everybody's got unlimited. But there is a fee, flat out, no matter what. Usually, most people's fee is related to their data plans. Okay? And it's expensive, just FYI. you better tell your mom and daddy thank you if they're paying your phone bill, because let me tell you something. Phone bills are really, really expensive for no reason. Okay, so we make our table. Now, let's be realistic as far as the texts are sent, but let's not be realistic to y'all sense. So like y'all may send thousands of texts a day. All right, being teenagers. All right, we might, as adults, or depending on how much you're on your phone, you might send somewhere around. You might go 25, maybe 50, maybe 75. Okay, you ain't got to go crazy with it. You can use whatever values you want. Everybody's graph should be the same, just our scale may be different. Okay, so we fill it out. We've got 0.50 times 25 plus 20. 0.50 times 50, plus 20, and 0.75. 0.50 rather, times 75, plus 20. And I'll fix that one as well. Okay. Now, we work all this out. 50 cents times 25 is 12.50 plus 20 is 32.50. 32.5. So we got 25, 32.5. Okay. Just be glad that y'all don't have the bill set up like this anymore, because as much as kids text nowadays, it'd be a bad deal. 50 times 0.50 times 50 is 25 plus 20 is 45. And then 0.50 times 75 plus 20 is 57.50. Okay, so we got all these values. Again, if this was your own, you may not choose these values, and that's fine. But for this purpose, we're going to use these. So we got 25, 32.50, 50, 45, and then 75, 57.50. Okay, so we got these values. We're going to graph them. All right, so X value, again, look at the top of your paper. It's the number of texts sent. Y value is going to be your total cost. Okay. And then you can do your scale however you want. I may do 10, well, hold on. Probably going to go up by 20s this time. So 20, 40, 60, 80, 100, okay? Just so I know I have enough room. And then I'll probably go up by 10s on my total cost side. So I'll go 10, 20, 30, 40. Really, I'm going up by 5s because I'm leaving a gap in between, because I know I've got some fractional cost here. 60 and 70. Okay. Again, it's going to be a judgment call on how you do this. Two people may do the same problem, have different ones. It's up to you. Okay. So we got 25. That's 30. So 25, 32.50. Somewhere right in here. 50, 45. And then 75, 57.50. Again, some of these you're going to have to estimate just based off how I did it. If you didn't do it my way, yours may be more exact. Okay? And then we want to graph the y-intercept. How much is the monthly charge before you ever send a text? And it's $20. Now, do I draw the line or not? Can you send a partial text? No. Once you send, if you send one letter, that counts as one text. So this is a example of discrete data, and that's it. You don't draw a line. Okay. Now, while you're getting that written down, then on the next on the page that's blank, okay, you're going to make a verbal description. You can use these as a guide, but don't use the same problem. You got to write the you got to do the equation box. Define your variables, write your equation, fill out a table and graph. This is by yourself, not a group project. When you are done with yours, make sure your name's on it. You put it in the box. I know that your bell work's already in there. Go ahead and put it in there with that as well. This is for a accuracy grade, so take your time. This video is already 35 minutes long. That means you've got about 15 minutes to work on this. You don't have time to talk to your buddies. You got to get to work because you're not able to leave with this. Okay? Let's get to work. Be quiet. Work on that. Don't give the sub any problems if there's a sub in there. Work on it. You got to get this done. All right? All right.